Welcome to springlib.
We're told that an oil refinery is located on the north bank of a straight river that is 2 kilometers wide. A pipeline is to be constructed from the refinery to storage tanks located on the south bank of the river, 2 kilometers east of the refinery. We're told the cost of laying pipe is $400,000 per kilometer over land to a point P on the north bank, and $800,000 per kilometer under the river to the tanks. To minimize the cost of the pipeline, where should this point P be? To understand this problem, let's draw a quick diagram. So we have our refinery here. Then to the east of this, at a distance of 6 minus x, let's say kilometers, we have our point P on the surface, and then another distance x away, directly below this point, is the tank. The distance from the top of the river down to the tanks is 2 kilometers, and therefore the distance from the point P to the tanks, this is, by Pythagorean theorem, the square root of x squared plus 4 kilometers. Now the cost of laying pipes on land in millions of dollars, this is probably the easiest way to do this. This is going to be 0.4 times the number of kilometers, which is 6 minus x. And the cost of laying pipes under the river in millions of dollars well, this is going to be 0.8 times the square root of x squared plus 4 millions of dollars. Therefore, the total cost of laying the pipes in millions of dollars, which I'll call C, is the sum of these two costs, 0.4 times 6 minus x plus 0.8 times the square root of x squared plus 4. Now to find the minimum cost, we want to differentiate our cost function and find the critical points. So we take the derivative, c prime. Well, this is going to be negative 0.4 plus, and this is 0.8 times 1/2 is 0.4 times 2x over the square root of x squared plus 4. Which this is the same as negative 0.4 plus 0.8x over the square root of x squared plus 4. Now to find the critical points, we set this equal to 0. Solving for x, 0.8x over the square root of x squared plus 4 is equal to 0.4. So we have that 2x is equal to the square root of x squared plus 4. To solve this radical equation, we'll square both sides. So we get 4x squared equals x squared plus 4. At this point, we need to be careful to check for extraneous solutions at the end. So this we get 3x squared equals 4, so that x is equal to plus or minus 2 over root 3. Now, looking back at our diagram, see this only makes sense if x is equal to positive 2 over root 3. So we don't have negative x in our domain. Now, x can be as small as 0 and as large as 6. So this is a problem finding the absolute extremum of a function on a closed interval. So let's compare the cost at x equals 0, 6, and 2 over root 3. So we have c of 0 is equal to, if you plug this in, 4, and this is in millions of dollars. C of 6, if you plug this into the equation, it's 5.06, and again, in millions of dollars. And C of 2 over root 3, this is about equal to 3.79, also in millions of dollars. So to minimize the cost, we should take x to be 2 over the square root of 3, and so the point P is 6 minus 2 over root 3, which is approximately 4.85, and this is in kilometers, from the refinery.